Good day guys, today our group gonna give a presentation and this topic is about smart traffic management system. So next, I will introduce our group members. There are 3 members in our group in total. First of all, for me, Xiong Zizhen, my metro number is D2024 1113919, and next member is Azuri, and his metro number is D2024 1110503, and last one is Olive. His metro number is D02024 1110541. So in this part, I'm gonna introduce the article first. The article title is Smart Traffic Management System and International Journal of Computer Application, and it has another name is for short IJCA, and the author is Neil Lanke and the Shutter. So let's get into introduction part. I will explain it, and the article explained how IoT technology can help solve the problem of traffic congestion caused by growing numbers of vehicles and traffic lights that cannot adjust to real situation. The main objective the article to design the smart traffic management system that connects vehicles, reside unit, and sensor to share live data and control traffic more efficiently. The author developed an algorithm called REDVD, Random Early Detection for Vehicle Dynamic, for automatically change traffic lights based on the number of vehicles detected. The article also discussed several challenges such as keeping a fast and stable connection between vehicles and sensors, processing large amount of traffic data quickly, and ensure the system can work well across the big cities. Another challenge is making the system cost effective and compatible with different communication technologies. Overall, the study shows an IoT-based system can make traffic smoother, reduce delays, and support cleaner and smarter cities transport.
Okay guys, next is a sensor that use. The first sensor that use is a RFID reader, or we call that as a radio frequency identification sensors. It is when the vehicle passes a traffic signal, an RFID reader controller detects it and the number of vehicles. It will help the system monitor traffic flow and automatically adjust timing signal to reduce congestion. Next is communication methods. Communication between a vehicle and the traffic light is done through the radio frequency communication, or we call that as a RF communication, which is the core principle of RFID, radio frequency identification technology. So the step is, first, each vehicle has an RFID tag and the traffic light has an RFID reader. So when the vehicle approach the junction, the reader sends out radio wave that active the tag. The tag then sends back it to vehicle data to the center, to the reader. So this information is just forwarded to the traffic control center via GSM, or we can use also a GPRS, which adjusts the signal timing based on the number of vehicle detected.
Okay, for right now, we're going to talk about hardware and software components. For hardware, we're using RFID tags attached to each vehicle to store unique ID data for identification. And then for another one is RFID reader or controller installed at traffic light to detect RFID tags from vehicle and send data to the control system. For software, we're using controller software algorithm. For the step, reading and writing data from the RFID tags attached to vehicle, processing vehicle frequency, and then comparing the detected frequency with the preset threshold, and last but not least, sending control commands to change the traffic light signal. For technical component, the system uses a smart box system that connect traffic light to a central control center. allowing real-time switching of signal based on data received from RFID sensor through GSM or GPRS communication.
So let's talk about comparison similarities. Um, all three studies use RFID to collect data about the number of vehicles. So this is similarities. Right now, let's talk about the differences between Article 1 to Article 3. So first of all, I want to list sensor. For Article 1, we use RFID tags or readers. For Article 2, we will use sensor, IR sensor plus RFID. For Article 3, we will use RFID plus IoT modules. So secondly, I want to talk about the communication. For Article 1, we prefer to use CSM modules or CPRS. For Article 2, we prefer to use Wi-Fi between microcontroller and crowd. For Article 3, we prefer to use wireless network. Lastly, we're gonna talk about the system used. For Article 3, for Article 1, we prefer to use smart box system. And secondly, we prefer to use IoT audio system. For Article 3, we prefer to use IoT FID system. There are also some improvements I will list. First of all is IoT-based central control. Um, connect all traffic lights and sensor through IoT to a cloud server for real-time monitoring and automatically um, timing adjustment. And second one is emergency vehicle priority. RFID tagged ambulance or police cars trigger a green corridor along their route to ensure fast and safe passage. And last one is smart controller upgrade. Use FPGA-based controllers for faster processing, remote control, and flexible signal management. Lastly, I will make a conclusion. All three studies focus on improving traffic management through automation, IoT, and smart communication system. Over time, the technology has evolved from simple automatic signal like control to advanced data-driven system that use sensors, wireless network, and artificial intelligence, that is AI, right? Overall, the study showed how clear progress in how IoT and AI are transforming traditional traffic system into intelligence connected and environmentally responsible a solution for future smart cities. So that's all right.